Hi and welcome to the Critical Lowdown. Today I'm here with Mick McCarthy, the Chief Operations Officer at EPS Global, and we're here to talk today about outsourcing your component programming versus programming at ICT or in-circuit test. Welcome, Mick.
Thanks, Ciara.
So how does outsourcing component programming and packaging impact production line efficiency as compared to doing it at ICT?
Okay, so the whole idea of high-speed component placement and basically line yield, high line yield, is to reduce the complexity of the processes that you are going to carry out on your line, and to increase the throughput. So a surface mount line is a very expensive piece of equipment, $3, $4, $5 million, with all sorts of processes built in there. And it's supported by a number of types of really expert people. And when we're talking about taking component programming off the line, it's the test engineering management group that gets affected by that. So their job is to basically manage the test process. And that involves managing the test algorithm itself, which is a really, really complex algorithm, and also then to manage the programming algorithm, because when you're programming at ICT, that's an extra resource. So what we suggest to those people is that by removing the programming activity from ICT, it simplifies their life. And we have some funny little stories about that. But basically...
Care to tell us any?
Well, maybe not today, maybe another day. But it basically simplifies their life if they just have to deal with the algorithm that tests the components as they're mounted on the board. So by making a decision to move component programming away from ICT, it means that somebody like us pre-configures the component so that when the component is placed on the board, it's immediately live. It has everything it needs. It has the intelligence of the firmware already embedded into it. And the board, in a lot of cases, lights up quicker.
Okay.
So that it helps, as well as the fact that there's no programming algorithm required, it helps the board to communicate quicker with the bed of nails and with the ICT tester. So that's one of the big advantages. And particularly for longer programming times, like anything over 10 seconds is considered to be, something that has to be taken into consideration. If you're talking about the number of boards, say you're getting 1,000 boards through your line, you probably have to significantly increase the number of testers that you're putting into your line, because that's always a bottleneck. ICT is always a bottleneck. These testers tend to cost $1 million each. And if you've got to stick 4 testers into the middle of your line, as well as creating the bottleneck, it's also an extremely expensive activity. And also it means you need to replicate the actual test beds themselves. So this becomes a very expensive process in order to increase your line throughput. Whereas if you can manage your test algorithm in a period of time that is reasonable and works in with the beat rate of your line, well then you significantly increase your throughput.
Okay, and just for our listeners, you mentioned a bed of nails. What's that in a just really quick explanation?
Well, it's a test fixture that basically sits down on top of the board after the components have been mounted, and it makes physical contact with all of the major components to be tested, and basically runs through, makes sure that these devices have been mounted properly, that there are no high legs, that all of the solder joints are working, etc., etc. So it's an expensive fixture that is bespoke to each individual version of the board.
So what kind of resources would you need if you decide to do programming in-house?
Okay, essentially, if you are deciding you're going to do your own programming in-house, online side, or whatever, you need to decide what sort of equipment you're going to program it on. You need all of the correct adapters, and those adapters are specific to the chip size and type and layout that you have, so you need to manage all of your adapters. You then need to have some sort of software to control that process. And where a lot of people get bad results from programming themselves offline is where the actual programming process itself is not well controlled. The main business of most contract manufacturers or tier one automotive guys is chip shooting and basically getting a board to a stage where it's testable and ultimately passes functional test. But again, in the area of complexity, by deciding to do offboard programming, you're adding more complexity into your business. Now you need to control all the software revisions of the chips you're going to program. And in general, if I can draw a parallel between the types of resources that we employ in our business, it might help to just illustrate that. First of all, our ERP system is based around component programming. It's based around component prep. And the most important thing from our point of view is that the IC gets programmed to the correct revision. And in this situation, you're starting off with a blank part number and you're ending up with a different part number because we're reconfiguring the chip by the insertion of firmware in there. Our ERP system is based totally around the control of all of the, number one, the chips themselves and the software that's put into those chips. So in general, we will have in our programming centers, we will have that, it's the same software all around the world that we use. We will then have our operations manager. Our operations manager is the guy who oversees the operations and is the guy with, all of the specific programming experience, who knows what sort of resources he needs. Clearly, a quality manager is required, and in some of the industries we work in, like automotive and medical, the quality standards are very exacting. We get audited all the time by our customers to make sure that we're always compliant, and we need to hold all of the necessary certificates. We have production controllers to basically plan our production so that we're utilizing our scarce resources as efficiently as we can. We then have supervisors and operators who manage the day-to-day requirements of producing the components. Additionally, we make all our own handlers. We design and build all our handlers in Brno City in the Czech Republic. And we designed them to be very integrated. So if you were to try and compare our handlers with other handlers out there in the market, we're doing all of our 3D coplanarity checking in line. We're doing all of our automated optical inspection in line, all of our laser marking in line, so that what we're doing is we're taking the blank device out of the packaging, be it tray or reel. We're presenting it to the programming heads. We're inspecting after programming that we have not in any way denigrated that chip, and we have log files to prove that this physical chip is as good as it was before we touched it. We then laser mark it. It then gets inspected automatically and put into tape automatically, and then the carrier tape is sealed and reeled. So it's a very simple integrated process from our point of view that causes very, very rare quality problems.
It sounds like it's all based around quality, traceability, everything is tracked.
Absolutely, yeah.
So there's quite a lot of resources involved between machinery and staff to manage that machinery and to manage the process, and the ERP system that provides this traceability and quality. So that's what's required if you want to do this yourself.
Yeah, absolutely. So usually our staff lineup within our programming centres, we have a customer-facing team, and that customer-facing team will interpret the requirements of our customers, which can be quite complex and which can be very time critical, and to transmit that into our ERP system so that our production group are flagged to produce the correct devices on time. And we then have our entire quality team overseeing the process. We have special capabilities in label production, in traceability, in making sure that the the devices, for instance, the out of packet time is timed all the time because these are all moisture sensitive devices. So our systems are totally designed to manage the delicate components and to get the right version of software into those components, get them packaged up again in time properly so that they and properly labeled so that they ship to our clients.
For manufacturers considering a shift to outsourcing their programming or taking the programming offline and allowing EPS Global to provide this service, what key steps should they take to evaluate and implement the pre-assembly programming?
Okay, well, clearly contact our local representative, but you know, they should overview their own production process and try and identify possible advantages. So if they have a look at the bottlenecks in their production process, they might see that they could increase their throughput or their line yield or their test capability by contacting somebody like us. We have 22 programming centres around the world. They're all located in areas of volume manufacturing. We've deliberately picked out those areas. I think we can safely say that we're covering most areas in the world where this stuff happens. And, you know, contact our local representatives and just understand that the experience we've had for the last 25 years of working with people's production schedules can be used to increase their own local situation and basically get more value out of their plants.
So I guess the message here is to use EPS Global's vast experience and resources to save time and increase efficiencies and reduce costs.
Absolutely, yeah.
Okay, that's great. Mick, thanks for your time today.
No problem at all, Ciara. Thanks.